Hello and welcome to All About Spatial in Oracle Autonomous Database. I'm David Lapp, a product manager on the Spatial team. This is going to be a fairly high-level overview of Spatial from the developer perspective. If you're interested in just a more general introduction to Spatial in Oracle Autonomous Database, then I encourage you to first view the session called Get Into the Zone with Spatial in Oracle Autonomous Database. It's another session offered on demand. In this session, we'll be quickly looking at Spatial in terms of an overview, but then getting into the way that developers work with Spatial in terms of APIs, mid-tier components, integration with other features of the Converged Oracle database, and touching on Python. So quickly, what is Spatial? Spatial is all about location and location relationships. Everything happens somewhere. All the information that we manage in our systems at some level could be related back to location. And what Oracle Spatial does is allow you to manage location as just another data element within the Converged Oracle database. So the location context of business information is stored alongside all the other business data that you manage in the Oracle database. And that goes for Oracle database in the Oracle Cloud, of course, including Oracle Autonomous Database, as well as Cloud at Customer and your on-premises Oracle databases. Along with the native management of spatial data in the Oracle database are APIs that allow you to ask all kinds of location-based questions that are important for business concerns, like how far are your assets away from some type of hazard zone? Which tax region or sales territory are locations contained by? And finally, this is all surfaced through business applications across many verticals and many industries that all benefit from the ability to incorporate location relationships, and of course, interactive maps. The spatial features of Oracle Database are quite uniquely open and interoperable. Developers, which is the focus of this session, access the features of Oracle Spatial, I'd say first and foremost through the native SQL and PL/SQL APIs. That means that all of the the traditional skills and techniques used for working with SQL and PL/SQL just naturally and seamlessly apply to location-based and spatial operations. And there's a vast API of spatial operations through SQL and PL/SQL. Oracle Spatial also has a native Java API, an integration, easy integration through Oracle REST Data Services, as well as Oracle Application Express. And both Python and Node.js applications can easily leverage the features of Oracle Spatial through Oracle's native drivers. And there are also a series of mid-tier components that I'll touch on in a few moments that ship along with Spatial at no extra cost. Now, in addition to developer access through all these programmatic interfaces, Oracle Spatial, due to its open interoperable nature, is leveraged across the entire geospatial software industry. That goes for both commercial and open source platforms. All of the leading GIS platforms and tools support Oracle Spatial as a storage architecture for geospatial data that their tools can access and operate on. Similarly, the leading commercial and open source geospatial data integration platforms natively support Spatial, as do commercial data providers and a wide range of our partners that have built industry solutions on top of Oracle Spatial. At its core, Oracle Spatial provides a native spatial data type and along with that, a native spatial index. And you can see here on the left is an example of a table called warehouses, and one of the columns in that table has a data type of SDO geometry, and that is the name of the native spatial data type. You can see that that column has been named geometry, but the column could be called anything. The important thing is that the data type is SDO geometry. That's the native data type. It just is another data type that sits along other fields in a table and stores all the required types of geospatial data that are needed to answer important business questions. And those are things like points, for example, geocoded address locations, polygons, like, for example, sales territories or hazard zones or zip codes, and lines, for example, road center lines or electric utility lines. Now, point geometries can be quite easily created from coordinates. For example, if you have a table of GPS coordinates, using SQL, these geometries can be easily constructed and indexed. Similarly, spatial data is oftentimes exchanged or downloaded from public sources in a variety of very standard, well-adopted spatial file formats, which are easily loaded into Spatial as well. In fact, we have a tool, Spatial Studio, that I'll be talking more about in a few moments, that can load from those formats. And in the case of polygons and lines, those are generally loaded into and built by loading from any of these standard formats. So I'll be getting into that a little bit more when I talk about Spatial Studio, but the upshot here is that geospatial data, location data, is stored as just another data type in a column in a table, and it's capable of storing points, lines, polygons, as well as other more advanced forms of geospatial data. Along with the native spatial data type and spatial index is this vast array of SQL and PL/SQL operations that you can perform to answer all kinds of location-based questions. Questions having to do with proximity, containment within regions of interest, identifying places where one feature overlaps another feature. It's all readily available through the SQL and PL/SQL APIs. We'll take a look at a couple of examples. First, here is a query that will identify which store locations are located within a flood or hazard zone. So in this case, we have a table called branches, which stores information about individual branch locations of some type of store chain. And that table includes the geometry, the location. And we also have a table called coastal zone, which is a table storing the information about and the geometry, the polygon that defines a coastal hazard flood zone. So this query uses a spatial operation that you see surrounded by red there, SDO any interact. And that's a spatial operation that just identifies which items among these store locations have any spatial interaction at all with this coastal flood zone. And any spatial interaction means that it's sitting inside of that zone or even sitting right on the edge of it. And we can see that it gives us a response. So now we'll look at another example. This time, instead of dealing with containment, this one deals with proximity. So again, we have the same branches table that has information about store locations, and also this time we have a table called warehouses, which has information and locations of warehouses that presumably serve these store locations. So in this case, the question we want to answer is, which are the 5 closest stores to a particular warehouse? And you can see that the spatial operator we're using this time, you can see sort of circled in red, is something called SDONN, where NN is an abbreviation for nearest neighbor. So put in different words, we're looking for the stores that are the nearest neighbors to a particular warehouse. You can see this is just simple standard SQL using just a built-in spatial operation, and we can see the response below. Now, in addition to the in-database SQL and PL/SQL APIs, Oracle Spatial also has a native Java API. And the Java API is meant for scenarios where you've got a client-side application potentially disconnected from the database, and you need to perform the same type of spatial comparison operations, location relationship operations that you would be performing through SQL. So the Java API provides methods for many of the most essential operations that you find in the SQL API. And this API is used by numerous Oracle applications that operate in a sort of connected and disconnected modes. For example, Oracle's NoSQL and IoT streaming solutions. Now, I mentioned earlier that Spatial, in addition to the in-database features, provides a set of mid-tier components, Java EE components, that are basically applications that can be deployed to a JEE server and do useful things with the data that you have in Oracle Spatial. So those are as follows. First of all, there is an application called Spatial Studio, and that is amongst this set of applications. This is the one which is actually an end user web application. This is something that you deploy and then users access it directly. The other three are developer toolkits. So Spatial Studio is a application for sort of self-service access to the spatial features of the Oracle database. Spatial visualization is a component that that provides a spatial data server, basically the ability to publish data out of Oracle Spatial in standards-based formats that are supported across all popular mapping clients. Geocoding and routing allows you to create a mid-tier services for address geocoding and address-to-address routing. And OGC Web Services allows you to stand up a OGC web server that publishes data out of Oracle Spatial in an industry standard set of services according to the OGC or Open Geospatial Consortium specifications. These are a set of spatial data services that are adopted across the geospatial industry. Next, we'll take a closer look at Spatial Studio. So Oracle Spatial Studio's purpose is to provide simplified access to the features of Oracle Spatial by users that don't necessarily want to do any coding at all. There are useful features and aspects of Spatial Studio for developers as well, though. So just sort of looking at this from the developer perspective, we may begin with geospatial data in Oracle Spatial, and we may also have other data that we need to integrate coming from a variety of file formats. So Spatial Studio really begins with the ability to access data out of Oracle Spatial. If you already have data that has geometries, you can access it directly and start working with it. If you have tables in the database that just have coordinates or addresses, you can access that data and prepare it by geocoding it and creating geometries from that data. The next thing you can do is load data from common formats into the database. So if this is something like a spreadsheet or a CSV file, you will load that data. Then you could then go on and do the preparation, the geocoding, and so forth using Spatial Studio. And if you have data from standard file formats. So those would be shape files, GeoJSON files, KML files. These are standard formats for exchanging geospatial data. Spatial Studio provides a user interface for drag and drop loading of that data. When you load one of those spatial formats, it automatically creates the geometry and the indexes and everything that needs to be done to start working with that data. Now, once you have done all that, you have data that already existed in the database or data that you've loaded. Spatial Studio allows you through drag and drop to create interactive maps and perform spatial analyses. Invoke those spatial queries that we saw previously through SQL, but just do it through a GUI. Now, once that's been done, the analyses that you create through drag and drop, those can be sort of introspected. You can look at those in Spatial Studio and see the underlying SQL that was created to build those queries. Now that's something that could be useful for developers if you wanted to, for example, start with a basic proximity analysis. We looked at what are the 5 nearest store locations to a warehouse. Well, you could use Spatial Studio to create a basic example of that. Spatial Studio will show you the SQL, and then you could be off and running to do some maybe more complicated or integrated examples where you want to use that as a start point. And similarly, once you do analyses and work in Spatial Studio, the results are automatically exposed as a REST endpoint, a REST endpoint that delivers your spatial results in this one of the formats we see below, GeoJSON, which is this standards-based format that all mapping clients can communicate with. So you're able to see the SQL that was used to create an analysis, and you can programmatically access results through the automatically generated REST endpoint. And then finally, from the developer perspective, the interactive maps that you create in Spatial Studio, again, through drag and drop and without the need to do any web coding, these interactive maps that you create are embeddable. Spatial Studio allows you to configure those maps so that they can be embedded into another application programmatically, for example, embedded into an iframe in another application, preserving their interactive behavior. So again, while Spatial Studio's sort of primary purpose has been for just pure self-service no-code access, there is at the same time a lot of benefit, a lot of value for developers in being able to use these features of Spatial Studio to simplify access to Oracle Spatial. Now that we've talked about Oracle Spatial's native SQL and PL SQL and Java APIs and the mid-tier components that come along with Oracle Spatial, let's look at the way that Oracle Spatial can be blended with other converged features of the Oracle database. The first of those converged capabilities that I'll talk about is Oracle Database's native JSON handling. That's, of course, a big deal because it means that you can do schemaless development in Oracle Database. You can drop all kinds of JSON into the database and it's schema on read, and you've got a tremendous amount of flexibility. That becomes a really important point when it comes to spatial as an integrating component. When you're dealing with sort of schemaless development, and you sort of, by definition, many times will not have any sort of natural key, primary key that you would join data sets by, location and location relationships end up becoming a real pivotal integrating data element. You can join and associate data based on location, when oftentimes that's really the only way to associate data. So within Oracle Database's native JSON features is a function called JSON value, which allows you to pull columns out of JSON content in the database, and you can then use that capability to perform just all sorts of standard SQL analyses and do your common sort of SQL work against data stored as native JSON. And that native JSON value function is integrated with Spatial so that JSON data stored in the standards-based GeoJSON format is automatically returned as our native SDO geometry data type. So what that means is that you can apply spatial operations, spatial analyses, and computations on native JSON data using Oracle's native spatial features. And that in turn makes it very practical and very feasible to apply location analysis and to create relationships between JSON data based on location. Now, in addition to the fact that Oracle's native JSON value function can return our native geometry, we also have built-in conversion functions that allow you to seamlessly move and view spatial data that's stored as our native type as GeoJSON and vice versa, to be able to take native data stored as GeoJSON, view it as our native type. So there is a seamlessness and a real sort of transparency of the way that spatial data is handled between JSON representations and the value of that, and our native spatial data type representation and all of the power that comes with that in terms of using our spatial operations. So JSON handling integration with spatial is very powerful in terms of integration of data through location. The next feature, and something that really builds on that JSON message, is the ability to take advantage of Oracle REST Data Services, or ORDS, with Spatial. Now, ORDS, Oracle REST Data Services, is a standard feature, comes along with the database, with Oracle Database, and it allows you to REST enable or create REST APIs and REST endpoints for really anything in the database. It's just not a spatial feature by any means. It's just a standard feature of the database. The beauty here is that because the spatial features of Oracle are all just sort of mainstream built-in features of the database, you're able to take advantage of all of those spatial operations in what Oracle REST Data Services publishes. So that means we can easily create location-enabled or spatial REST APIs that do things like ask questions about proximity and distance and spatial relationships, and even return spatial geometries through REST APIs using this built-in feature. So in the example we see on the screen here, Oracle REST Data Services simply defines a series of endpoints that will invoke backend or database operations and expose it as a REST API. In this case, it's an API that is asking really that same nearest neighbor or proximity question that we saw when I showed the SQL example earlier. What are the 5 nearest store locations to a warehouse? Well, this is taking that exact same query, but turning it into a REST API through Oracle REST Data Services. Very straightforward and very powerful. So one more converged feature of Oracle Database that has a strong integration with Spatial is Oracle Application Express, which goes by Apex. Now, Apex is, again, just another converged feature of Oracle Database, comes along with the database. It's nothing that's purchased or licensed separately. And it allows you to create very powerful, robust, scalable web applications completely driven out of the database. Now, because of the fact that Apex is database driven, it's able to take advantage of all kinds of converged features of the database, and that includes spatial. So in an Apex application, you are going to be rendering and displaying the results of all sorts of queries and operations that you do in the database. So of course that can include all the location-based and spatial things we do in the database. In fact, in addition to the charts and dials and gauges and tables and reports that you can use in Application Express, there is a map visualization that natively supports our built-in SDO geometry data type for creating maps. So if all the data that you have stored in Oracle Spatial, you can just very easily render in interactive maps within an Oracle Application Express page and dynamically render and color code and style the map based on your data. Now, of course, the other sorts of reports and charts that you create in an Oracle Application Express page are going to be driven by database queries. And so, of course, those queries could include location as well. Maybe you would have charts and tables that are presenting results that incorporate proximity and containment and so forth. So the menus and the controls that a user has in an Apex page could, and often are, incorporating location in the application. So Oracle Application Express is definitely worth a really close look when it comes to creating a real enterprise-ready web application driven straight out of the database. Spatial can also be leveraged quite easily from Python. Now, Oracle has created and maintains a module, a Python module called CX Oracle, which is our open source driver for talking to Oracle from Python. Now, the important thing about CX Oracle is that it has lots and lots of built-in capabilities to take advantage of advanced capabilities of the Oracle database. So that means that it's much more than just making a connection to an Oracle database. It's being able to connect to the Oracle database and have built-in features that know how to deal with various object data types, including our SDO geometry type, and lots of other advanced features of Oracle database that instead of having to code around them or integrate them with Python code, those features are automatically handled by this Python driver, which allows you to quite easily bring data out of Oracle into Python that you then want to perhaps blend and leverage through this vast ecosystem of geospatial libraries that are well adopted across the industry. So libraries such as Shapely and PySal and GeoPandas and so forth do all kinds of very specialized advanced geospatial data science. So you can use Oracle Spatial to do really the heavy lifting, the warehousing of geospatial data and lots of data engineering and pre-processing of vast amounts of data. And then through CX Oracle, you can invoke Spatial, bring the sort of the subsets you need in to Python, and blend that data with other specialized geospatial libraries. And that's been a really effective way to have the best of both worlds. So to summarize, Oracle Autonomous Database and all Oracle Database editions provide a uniquely powerful spatial data management platform. Spatial data management, analysis, processing. That platform is uniquely open and interoperable. So we looked at all of the in-database APIs, Java API, the mid-tier components, the ability of all these tools and platforms across the industry to support and take advantage of Oracle Spatial as a spatial data management platform. And then at the end of the day, of course, it's about being able to surface all of that power through business applications that address business concerns that have to do with location relationships, proximity, containment, and so forth. That's what Spatial is all about. So I certainly hope this has piqued your interest in Spatial. And if you would like to learn more, we have a series of resources that would be, I think, very helpful. In addition to the documentation and blogs and webinars that you see, down at the bottom here are a couple of links for our analytics and data Oracle user community that has a spatial tract within it. And I would encourage you to take a look at that in terms of getting yourself into the community of enthusiasts. So I hope this has been informative, and I thank you for your attention.